So I've gotten several emails from people saying, they have terrible difficulty accessing a book because of whatever. So I'm going to go ahead and give you some homework problems from this chapter 7, fluid pressure on a plate. Okay? So first problem is just something like a rectangular plate. Okay? Now for density, we can just always assume that the density is going to be 64 pounds per cubic inch. Okay? That's the density of our fluid for all the problems. All right, so the plate here, let's say this is the end wall of a tank. Okay, so the surface here is at 0. The tank is full of water. The tank is 4 feet deep, let's say, okay? And let's say the tank is, 6 feet wide, okay? So this is going to be problem number 1. Find the fluid force on the end wall of this tank. Then we can take the same idea and we can take another one here. Okay, we can make this one 3 by 5. Only we can put this one deeper under water. Okay, so let's put this one 30 feet underwater. So let's say this is in the ocean, and we want to know the pressure on each side of this plate. Okay, so same basic idea, right? So this would be problem number 2. Okay. Problem number 3 can be a parabolic shape. Okay. So let's say that we take our x squared, just a regular, the standard parent function parabola, and let's say that it's going to be 9 feet deep here. Okay, and I think that would make it 6 feet wide at the top, right? And let's say that this is just a tank, and it's full, and we want to know the pressure on the end wall of the tank. Okay. Problem number 4 can be to take the same idea and flip it upside down. Okay. So this tank, just to make it easy, can be let's say 4 feet deep, and I think that would make it 4 feet wide at the top. So again, same situation, full of water. This is the top of the tank, that's the bottom. What's the pressure on the end wall? And then number 5 can just be to take a parabolic shape and sink it under 20 feet of water. And let's use this one again. Doesn't really matter. Well, no, just to mix it up, let's make this 10. Yeah? And then I think the height of our window is going to be 25 feet. If I'm not mistaken. So there we've got 5 practice problems that you can do. So from there, we can change the geometry some. Okay, so let's say we've got a tank that's a trapezoid. Okay, so this tank can be 3 feet wide at the bottom and 7 feet wide at the top, and it can be 5 feet deep. And let's say it's full of water, and this would be number 6. So we want the pressure on the end wall of this tank. Okay. Number 7, we could use an ellipse. Okay, we could use an ellipse that has a height of 6 and a width here of, let's say, 9. Okay, so I think that's going to be x squared over what is it? When x is 0, this would be okay. So that would be let's make this 10. Okay, let's make it 10. So it would be x squared, I think, over 25 plus y squared over 9 would be 1. Okay, I believe that's the formula for that ellipse. So again, let's say that this is an elliptical tank, and we want the water pressure on the end of the tank. So this is the top, it's full. Let's just plug a number in here. So when y is 0, x is 5. Yeah, okay, it's good. So, and these are in feet. So that would be number 7. Number 8, we could take a perfectly round tank, okay? So we have a circular tank. Let's let the radius be 4 feet, okay? We want the pressure on the end of this one. And then we could take this tank for number 9, and we could use it as a plate, okay? We can say that this is a plate with a radius here of 3 feet, and let's say the plate, the top of the plate is 15 feet underwater, okay? So that would be number 9. And number 10, let's see, what have we done? We can just keep track. Oh, here's one you could do. You can do a square plate that's set at 45 degrees. So this is 4 feet, it's a square plate, and then let's put it 60 feet underwater, okay? So there you have 10 problems. If you can do these 10 in your notebook, this will cover this topic fairly well.